Yeah, okay. In this video, we'll start the second part in solving exercises about the chemical bond. In exercise 4, we have the following two structures. For a certain compound has a molecular form CH3ON molecule. It can be represented by two different structures as represented in document 1. Refer to structure 1. According to this structure, justify whether the oxygen atom attains stability or not. In order, we want to determine if the oxygen, هل الأكسجين becomes stable with satisfying the octet rule or not. If we look to the structural oxygen, we have two pairs. We have a lone pair of electrons. We have two electrons. Here another two electrons, and we have 4 electrons. And every shared pair represents 2 electrons. We have here 2 electrons and 2 electrons. So we have 2, 4, 6, and 8. So oxygen satisfying the octet rule and become stable. Then oxygen atom has 2 lone pair, yani there is 4 electrons, and share 2 electrons with carbon, and we have here 4 electrons. We have shared 2 electrons with carbon. With a total number of shared electrons, we have 4 electrons as a shared of electrons. So the total number of electrons is equal to 8. So it satisfies the octet rule. So it is a stable, or the oxygen atom attain stability. Then it attains stability. Okay. Indicate the number of valence electrons in nitrogen. How many valence electrons? According to the Lewis dot symbol, we have a lone pair of electrons. We have 3 shared electrons with hydrogen and carbon. So the number of valence electrons is equal to 5. So the valence electron in nitrogen is equal. في عندي lone pair plus 3 shared electron or 3 bonding electron. So we have 2 plus 3 is equal to 5 electrons. Deduce the valence of nitrogen atom. Since it have 5 valence electrons, it need 3 electrons to satisfy the octet rule. To satisfy the octet rule. So the valence is equal to 3. We have 5 valence electrons. In order to become stable with octet rule with 8 electrons, so it needs more 3 electrons to become stable. Or we can write the Lewis dot symbol of nitrogen. Also, we can write the Lewis dot symbol of nitrogen. Nitrogen has a 5 valence electron. So the number of single dot electrons is equal to 3. So the valence is equal to 3. Referring to document 2 of the structure 2, specify the type of bond. We must explain what is the type of bond between carbon and nitrogen. Let's go back to the structure 2, structure between carbon and nitrogen. Okay, we have carbon and nitrogen. Here we have a double covalent bond. We have sharing of 2 pairs of electrons. So we have a double covalent. Okay. Carbon share 2 electrons with nitrogen atom. Then the bond is double covalent bond. So the type of bond is double covalent bond due to the sharing of covalent bond, sharing of two pairs of electrons between carbon and nitrogen. Give the name of the bond formed between oxygen and hydrogen. If we return back to the structure between oxygen and hydrogen, we have oxygen and hydrogen. We have sharing of one pair of electron, so the bond formed between carbon and between oxygen and hydrogen is single covalent bond. Okay, the type of bond between oxygen and hydrogen is single covalent bond. So single covalent bond between oxygen and hydrogen. Determine the number of valence electrons in oxygen. If we return back to the lowest structure, in structure 2 we have lone pair. We have two lone pair. We have 4 electrons, and we have a shared electron with hydrogen and a shared electron with carbon. So we have a total number of electrons. We have 2 and 2, 4 and 5 and 6 valence electron for oxygen atom. How to write the answer in question like this? In order to determine the number of valence electron, or the valence electron in oxygen atom is equal to number of lone pair electrons plus number of bonding electrons. We have two lone pairs, and each pair containing 2 electrons, plus we have 2 bonding electrons, one with hydrogen and one with carbon. So we have 2, the total number is 6 electrons. Deduce the number of valence electron in oxygen atom. Valency of oxygen atom, since it has 6 valence electron, so it need 2 electrons to satisfy the octet rule. So the valency is equal to 2. In exercise 5, we have a document to present the different levels, the levels dot symbol of different elements. Okay, we have potassium and calcium are 2 metallic elements, and the others are non-metals. Identify or indicate the valency of potassium and sulfur. Indicate without reasoning, since the potassium is K, potassium K and sulfur is S. Potassium has a 1 single dot electron, so the valency del K is equal to 1. And sulfur has 2 single dot electrons, so the valence is equal to 2. Valency of sulfur is equal to 2. Explain how the formation of bond in potassium sulfide between these 2 elements. What is the type of bond? Since we have valence equal to 1 for potassium, so potassium loses 1 electron to form a potassium ion K plus 1 ion, since it has 1 valence electron. And sulfur has 6 valence electrons. Sulfur has 6 valence electron, so it gain. If potassium lose, the other element with it will gain 2 electrons to form as 2 minus ion and attain stability, attain stable octet rule. So the bond is then the bond formed between these two positive ions, these ions, one potassium positive ion and sulfide negative ions. Then the bond is ionic bond. And we write the definition of ionic bond with electrostatic force of attraction. So it is an electrostatic force of attraction between the opposite ions. This is the definition of ionic bond. Specify how each of calcium and chlorine atom attains the octet rule. How calcium, it has, this is the calcium, has 2 valence electron. So calcium lose 1 electron, or sorry, 2 electrons to be stable, octet rule. Whereas chlorine, which is chlorine, we have 7 valence electron here. We have 2, 2, 4, 2, 6, and 1. We have 7 valence electron. Then it will gain 1 electron to be stable octet rule. Here it has, the reason has 2 valence electron. It has 7 valence electron. Write the formula unit of potassium sulfide and of calcium chloride. We have, for potassium sulfide, we have K plus and sulfide 2 minus. So the formula unit of the ionic compound is K2 and S2 is written below. For calcium chloride, calcium as a negative positive ion, since it loses 2 electrons, it will become positive ion Ca2 plus. Chloride gain 1 electron, become Cl minus. So the formula unit is CaCl2 by using Kitts-Cross method. This 2 is written here for chlorine. In order to write the Lewis dot structure of the following compound, for methane, we will use the Lewis dot symbols that are given in the beginning of this exercises. For methane, we have the carbon has Lewis dot symbol as with 4 electrons. So everyone is related or shared to or bonded to hydrogen. So this is the Lewis dot symbol of methane. Methanoic acid, we have CH2 and O2. We have carbon and 2 oxygen and 2 hydrogen. Methanoic is then we have carbon and we have 2 oxygen. We write oxygen to the right and oxygen to the left. This is the carbon. This is the oxygen with 6 valence electron. And here oxygen, we have share and share of electron. This is the Lewis dot symbol of oxygen. We have sharing of electron and we have 2 hydrogen. This electron is bonded to hydrogen and this electron is bonded to hydrogen. So we have a single and double covalent bond in methanoic acid. Hydrazine, we have 2 nitrogen and 2 hydrogen. Nitrogen, we write the Lewis dot symbol of nitrogen, and we have 5 valence electron for each one. Then we share, these pairs are joined to each other forming single covalent bond. The other, we have 2 hydrogen. So one for hydrogen here, 1 is bonded to hydrogen and this electron will share each other, forming double covalent bond between nitrogen and single covalent bond between hydrogen. We have hydrogen cyanide HCN. We write carbon as a central atom that has highest valency or single dot electron, and we have nitrogen. We have 5 valence electron, and we have hydrogen. So 1, 2, and we have 1 hydrogen. If we write hydrogen here, this means we left these 2 electrons as unpaired or unshared. So hydrogen must be here shared with carbon in order for the carbon share the other electron with nitrogen, forming a single covalent bond with hydrogen and triple covalent bond between carbon and nitrogen. For ethane, we have 2 carbon and 6 hydrogen. For ethane, we have 2 carbon and 2 carbon, 1 and 2. This is the lowest dot symbol for each carbon, and we share 1. We have 6, then we have 6 single dot electrons, so each one will correspond to hydrogen atom or shared with a hydrogen. 1 2. فإذا أنا بنعمل sharing لكل إلكترون مع كل hydrogen. إذا each electron, single dot electron of carbon is shared with hydrogen atom in order to attain stable octet truth. This is an ethane. And the last one, this is C2H6O. He says that it has 2 possible lowest structure. Okay, 2 carbon, we write for C2H6O. We have 2 carbon and 1 oxygen. I write oxygen to the right side. Carbon, 4 electron, each carbon. Oxygen, we have 6 valence electron. Let's start successfully by 1 pair or 1 share of electrons as a single covalent bond between carbon and oxygen. The other, we have a 6 hydrogen. We have 6 hydrogen is an 1, 2, 3, 4, 5, and 6. So is an these 6 valence, 6 single dot electron here. 1, 2, 3, 4, 5, and 6. Is and they are corresponding to the shared electron with hydrogen. So we have this electron shared to hydrogen atom, hydrogen 3, 4, 5, and 6. What will be the other possible structure other than that? We rearrange the carbon and oxygen. We can write them carbon, oxygen, and carbon. Then we change the arrangement. Also 1, 2, 3, 4. The oxygen as a lowest dot symbol, as a single dot electron here, and carbon has 4. And we make sharing between oxygen and carbon by single dot electron. If we count the single dot, the remaining single dot electron here, we have 1, 2, 3, 4, 5, 6. So these are electrons that share to hydrogen atom. So 1, 2, 3, 4, 5, and 6. These are the 2 possible lowest structure of C2H6O. Thank you.